हे गाइस, वेलकम बैक टू थिंक टेक। और आज के पॉडकास्ट में हम लोग AWS के बारे में बात करेंगे। मेरे साथ नितिन है। नितिन अमेजोन में सॉफ्टवेयर डेवलपमेंट इंजीनियर है। तो हम लोग आज AWS को अंदर समझेंगे, मतलब हाउ डज इट वर्क, हाउ वाई इट इज़ सच अ फेमस प्रोडक्ट है, और सारी बातें करेंगे। उससे पहले एक छोटा सा इंट्रोडक्शन नितिन का।
Yeah, hey Shivam, thank you for having me. My name is Nitin. I have been with Amazon for approximately 4 years now. I started with Citigroup in Pune, and right now I am an SDE with the Eco organization in Amazon, which falls under AWS, and we are building the next gen version of the shopping cart, which is also the smart cart. That's what we are currently working on. Yeah, it's exciting work. Good to be on your podcast.
Thank you. So I think Nitin and I have a history that goes long back. We were college mates during our bachelor's, and then we have known each other for more than 10 years. So it's more of a friend-like conversation, but we'll discuss mostly about AWS, or we'll try to keep it very technical and give you an inside perspective of how AWS feels or looks like to an Amazon employee. Most of us would have used it as an outside user, with little visibility to how the internals work or why it is such a famous product. But today we'll understand everything from in and out. So I think we'll start with a very basic question: what AWS is. Like, if you have to define AWS to something, then what is it?
Yeah, so AWS, like most of us know, it stands for Amazon Web Services. And what has happened is that the challenges that companies had when they used to build their products earlier on was that they did not have those tech stacks available like so easily. They did not have tech stacks available at their disposal. So it was really difficult to come up with a product because there were so many challenges with respect to the tech stack, with respect to scaling, with respect to how cluster management will take place, with respect to costing. There were so many things which the companies needed to figure out. Now with AWS in the scenes, the thing is that you can just focus on the business logic, and you can delegate most of the parts when it comes to infrastructure management, when it comes to scale, when it comes to the best choice of the compute, when it comes to the best choice of the service for a particular feature, for a particular product. All of that can be delegated to AWS. So AWS is making our lives easier in the sense that you don't have to worry about that stuff anymore. So that's I think has been a big revolution over the years, and it's also testified in the way how some of the companies have been using AWS. So all of us in India at least, we are big fans of cricket, and IPL is a phenomena which happens every year, and it runs for approximately 2.5 months. The most part of that streaming is being supported by AWS Lambda. So that is one part. Then you have companies like Washington Post, you have New York Times, and several other companies which are using the AWS based stacks now. So this is how I believe the AWS is simplifying the lives and making it more and more easy for companies to adopt new technologies. So that's what's been the...
So I think one main benefit, or few main benefits of having a service or a platform like AWS is that you get on-demand scalability.
Correct, yeah.
Which is, I think, one of the most important components for applications who do not have a constant load, right? Because a lot of applications, they either have a seasonal load, or they have loads like for IPL streaming when some important events are happening. And the second benefit that I've heard most people talk about is unit costing, because you do not have to pay for the infrastructure while you're not using it.
Correct. So the model is you pay for what you use.
What you use.
That's what the model is.
Yes. But my question basically is that if these things, or these are something that are inherent to a cloud platform, be it AWS, be it Azure, be it GCP.
Correct.
But what is AWS doing different from these platforms that is making it so popular, or what is the USP of AWS that it has seen such a wide scale adoption?
Yeah, I think the first and foremost is the ease of adoption. You have an AWS console, like it's kind of a marketplace. You have all the services available at your disposal, and it's so easy to select one of the services and get started right away. So that has been one of the biggest USPs of AWS. Like, you don't have diversified platforms wherein you need to go and you need to basically decide upon what should be used. Then I think it has also been one of the I would say the thing that has gone into AWS's favor is that it has been the pioneer when it comes to the cloud computing platforms. So it's already leaps and bounds ahead of its competitors, be it Azure, be it Google Cloud. So there are so many reference materials available online when it comes to AWS. So people don't really have difficulty navigating their way to AWS, and it's very close to the some of the open source things which are already available. For example, Kafka.
Yes.
Some of the databases, for example, it's pretty much based on that. So I believe that's one of the reasons why AWS has been so successful. Adoption is like definitely one part, and the second part is that it was able to start very early, to be able to anticipate the market needs, and to be able to create a cloud. I think that is what's benefited AWS a lot.
तो आई थिंक हाँ मतलब फर्स्ट मूवर एडवांटेज
Correct,
तो
yeah.
था ही अमेजोन के पास. दैट इज अ वेरी obviously if you excel in something and you pioneer you always get that advantage. Second thing, what interesting thing you said was कि हम लोग or you also support open source
Correct, yeah.
technologies like Kafka
Yeah,
or
yeah.
maybe HDFS or something like that. तो उसका क्या मॉडल रहता है? Like you take the open source product, you add something to it, or you just provide a wrapper on top of it, and in internal it is actually just that open source product that is.
Some of the products are pure wrapper, but कुछ हैं जैसे फॉर एग्जांपल इन्होंने स्क्रैच से क्रिएट किए. जैसे 2 और 3 एप्लीकेशंस मार्केट में प्रेजेंट थी जो कुछ कर रही थी. सो टू बी एबल टू ब्रिंग देम ऑल अंडर वन प्लेस, अंडर वन टेक्नोलॉजी. So that was that. But yeah, कुछ रैपर एप्लीकेशंस भी रहते हैं, ऐसा नहीं कि प्योर रैपर एप्लीकेशंस नहीं है. But majority of the stuff is what Amazon has built from ground scratch.
Okay.
Yeah, that is
Okay. So I think हाँ ये अब थोड़ा सा डिफरेंट एक टॉपिक पे बात करते हैं, क्योंकि वर्चुअलाइजेशन ऑफ और बेसिकली क्लाउड प्लेटफॉर्म्स इटसेल्फ हैज सीन अ लॉट ऑफ एवोल्यूशन. पहले वर्चुअल मशीन्स थी, फिर हमारे पास EC2 instances आए where basically it's a virtual machine but you can sort of very fine tuned, very granular level giving memory requirements, CPU requirements. उसके बाद फिर containers आए.
Correct.
Container orchestration बहुत famous हुआ, and now everyone is moving to serverless computing where Lambda functions or Lambda Y. So as an Amazon employee ये जो मतलब what is the percentage? Like we think कि आप पूरी दुनिया सर्वरलेस से मूव कर रही है, बस is it truly the case? क्या सारी applications और most of the use cases are moving to serverless, or there is still a fair bit of load on traditional virtual machines या traditional physical machines?
Yeah, so it's a very debatable topic actually. What happens is that when it comes to AWS Lambda, people sort of assume that it attains a nirvana state because the operational overhead with respect to AWS Lambda is very, very minimal. But some of the use cases cannot be supported using Lambda, right? For example, Lambda has certain limitations in the form of like it has a 15-minute timeout. There is a memory-based restriction when it comes to Lambda compute. The cold start issue is very prevalent. Although the cold start problem has been addressed to a great extent, but it's still an issue.
What is a cold start problem?
Cold start is that it takes some time for the when it's a fresh request to a Lambda function, it takes some time for that Lambda instance to come up, which adds certain latency to the API's call. So if you are building a very latency sensitive system, you would not expect your system to behave that way because it eventually degrades your customer's experience, correct? So that's what the point. That's the entire debate upon cold start. But like people have been using some of the ways to get around this cold start issue. For example, like there are certain things, some lightweight DI framework, choice of the language, not putting it inside VPC.
So choice of language also matters when you work.
Correct.
With
Yeah, it does, right? So that's why like Lambda has been evolving over the past few years. Like when it was initially launched, there were only a few languages that were supported. Now it's a like whole bunch of languages which is supported. I believe Node.js is the latest one that they've added.
Okay.
So yeah, so that matters. And coming back to the original question, like it depends, right? So if you have a very long running job, a job which can easily exceed 15 minutes of the time period of the time limit which is enforced by Lambda, then you would definitely not prefer Lambda function in that case, right? So you will probably want to move to some of the persistent computes, be it Fargate, be it EC2. So you'll have to take that trade-offs depending upon what the needs of your system are. Usually what happens is that we tend to go towards Lambda, obviously for the reasons that I mentioned. There is a cost analysis which we do. Then the scale is definitely one part. Lambda scales seamlessly. Right, there is a limit to that, but
so what is the limit to which Lambdas can scale? Like if
I think by default it's restricted to 1,000 instances, 1,000 concurrent instances. But there is a caveat with that limit is shared by Lambda functions in an AWS account. So if you, for example, if you have 10 Lambda functions running inside one AWS account, the 1,000 limit is not per Lambda function. That's the
and you can set it per Lambda function, or it is equally divided across?
There is a concept of provision concurrency and reserved concurrency wherein you can specify that what Lambda function gets what percentage. But then you're not basically utilizing the like you're anticipating the load of your application, and if it breaches beyond that limit, like you are bound to fail some issues in the live scenario. So that's what the problem is. But overall, I think Lambda has been doing really great. Most of the services, I would not say most, but people have a leaning towards Lambda function because of the ease of use that it brings. You don't have to manage operational part by yourself. The scaling is automatically managed. You don't have to worry about security groups, subnets, and all those things. So all of that information is abstracted out from you. So it operationally, I think it's very, very advantageous to have Lambda. But having said that, there are issues like we talked about with respect to the runtime, with respect to the memory. That is there.
So basically, when I think about this debate, right, like monolithic applications versus microservice applications, so what I feel is that you have to somewhere also factor in the ease of development, right? Because if you are building a monolithic application, then no doubt it is easy to develop. You can quickly write some code, maybe send out the first version of the product and see and gauge the demand or how your users are reacting to your product, right? As compared to if you do a full-blown serverless architecture and then you deploy it in a full-blown manner, and then you realize that whatever you planned for is not what your users expected, right? So do you also see this sort of a life cycle when you develop applications in Amazon, that the first instinct is to just quickly come up with something, deploy it maybe in an EC2 instance, one or two EC2 instances, and then once you have your you understand your market fit, or you understand who and how they are using your product, you sort of revamp your product, or from the very start you start your development keeping AWS Lambdas and serverless architecture in mind?
Not really, actually. It depends upon the requirements of the system. If there are too many APIs that the system is supporting at the same time, you don't, like if you're building things right from scratch, you wouldn't really want to go towards a monolithic architecture, because beyond a point it becomes too difficult to manage. That is one disadvantage. And then how teams have been functioning inside Amazon is that like there is no clear ownership, right? It's not just about Amazon, any other company also. After some point in time, you would want to divide ownership, like the as per the business fit of the application. You would want to say that, all right, this is this entire system which is being supported by 10 applications right now. 2 of this will be owned by this team, 2 and will be in that direction. So in that case, I believe microservice architecture becomes really helpful. That is one point. And again, like it's putting everything in one place, which is kind of how monolith applications are built. I think you are more vulnerable to the single point of failure thing, which we usually avoid in a software development cycle. So wherever possible, we try to break our systems into logical entities. That's what the thing is. And even if that means that the application, so it's not like there is no compulsion as to create microservices. So if a monolith application is very well capable of handling something, you don't really break it into microservices just for the sake of it, right? So the architecture per se is not very bad as long as it's manageable. So that's what the take is. But overall, I would say the leaning has been towards the microservices based architecture.
And basically your experience using an AWS service or AWS product, is it comparable to someone who is using it from the outside? Like the same level of abstraction is created when you use AWS? So there is no visible difference as to if you are using it from
I think AWS has been very transparent in that sense. Like whatever it's offering to external users, external, the same is being offered to internal. So always there will be a cost trade-off, because you are internal, you will not pay what the external users are paying for it. But apart from that, there is no feature restriction. Say for example, AWS says that this is a very good feature, but we'll just use it internally. We won't expose it to the end users or to our competitors for that matter. So that level of transparency has always been there when it comes to AWS.
So that is actually a very good point. Your competitors are also using AWS, right? So how does that actually work? For example, if I have say Walmart, right, who is competing with Amazon in the retail space or maybe in the physical store space, but do they also use AWS, or how do Amazon handle this? Is there any policy around it, or is there any guidelines around these companies using it?
I'm not sure, to be honest, but I don't think there is any like Amazon usually says no to its competitors. Like that's the democratization of the technology that we're talking about here, right? It should be accessible to everyone. Like if your competitor is building a product which is good enough, you take that as an inspiration and you build a better product, right? But you don't restrict them, you don't deprive them of the opportunity, because you are kind of selling yourself as like the open source version, right? Anybody is free to use AWS. So don't usually restrict that.
Yeah.
And I'm not really sure of the legal part here.
Mm.
I'm not the right person to take.
Yeah.
But I guess there will be something, but not like the blanket no.
So now let us discuss a little more about lambdas. So lambdas, as I understand, is a stateless entity which you can schedule on any server. But when you think about the entire life cycle of how lambdas work, right, there are a little missing pieces, right? How does this end-to-end work? So if you would explain how does, from starting with the function, how does the end state where the lambda function goes live, how does that work actually?
So Lambda is a compute, right?
Yeah.
Like within Amazon, we are creating services which are wrapped around Lambda. So there is this concept of core Lambda endpoint, wherein what happens is that your Lambda function is fronted by an API gateway.
Okay.
So you are able to expose APIs, at the same time you are able to leverage the power of the Lambda compute.
Okay.
So API gateway, like it's in general how API gateway functions is that there are certain set of APIs which are being exposed. Now for that particular API, you create routes in that Lambda function, and now it's the API gateway's responsibility to, like there are internal things which are there in between, but how it functions is that it's the gateway's responsibility to route the request to the correct Lambda endpoint. Okay. So Lambda at the same time is supporting APIs also. That is one part.
Okay.
And the outside version of Lambda is that it's being used as a stateless function, an event-driven system. So for example, an event happens and you want to perform something as a result of that event, right? So in those cases, that Lambda function is being triggered. So that's one way to use it. And internally, how we manage it is that there is a full-blown CI/CD way of developing Lambda also. The idea being everything should follow a code review process. Because you're free to make changes in the AWS console also, right? You can deploy your own Lambda function, but then those things are not being monitored. So how do you effectively track the life cycle of your product end to end? So there are code review processes in place, there are CI/CD pipelines. So that is how Lambda is being developed today. There is no restriction when it comes to the choice of language for building a Lambda function. Teams are free to take that decision. Even the DI framework, the idea usually is to choose the lightweight DI framework, obviously for the reasons that we talked. But I think there has been no compulsion. It's just that just to keep the process standardized with respect to the software development life cycle, we are following certain processes.
I think good coding practices some or the other day will benefit.
Correct.
So one more doubt or question I had was that when lambdas are basically known to be stateless entities, right? They are getting triggered based on an event.
Correct.
So when a request comes to a lambda and there is something that it computes, how do lambdas share that information? Because after a few moments or few minutes, the lambda will go down, right? Whatever it has computed in its memory, if it is not committed to somewhere, it will go down.
Correct. Yeah.
So what happens? How do lambda communicate? Like lambda functions communicate with each other?
So lambdas can communicate with each other as long as there is no persistence element involved. Because lambda will
one lambda can call another lambda also.
It can, right? It's simply an invoke call. So one lambda function is free to call another lambda function, another lambda function is free to call next lambda function. The best way to manage it is to have an orchestration in place, which AWS is offering via step functions. So step functions are the way wherein you can orchestrate lambda functions. You can take decisions also. It's kind of like a state machine. So there is a state machine. Think of it like the output of the one is input to the another, so on and so forth. And in between those also, you want to take certain logical decisions. Depending upon the output, you want to make that decision. Do I invoke this? Do I invoke that? Something of that sort. So AWS step function has been a very good orchestration mechanism which AWS is offering, and I think it's been very actively used inside Amazon. So that is how it's being managed. But there is no restriction. Like one lambda function can call another lambda function.
And if there is a persistence element involved, then you have to commit that information to some storage. And
so what happens is that, like you said initially, like it's a serverless compute. It's a stateless system, right? So the caching, for example, the in-memory caching will not be very effective. Right. The reason is that lambda function will die down after certain duration of inactivity. Right. So the in-memory cache part is a drawback, but nobody is stopping you from using a distributed cache in this case.
You can use an external cache,
external
like
cache, Redis, memcache, whatever you want, so that you can use. But in terms of the efficacy of an in-memory cache in case of a lambda function, it's very, very poor. So I recently faced one issue while developing one application wherein I'd overlooked this factor, and the application wasn't serving a constant traffic, but when we published the metric around the usage of that metric, it was very poor. So every time we were ending up essentially making a service call. So cache in that case wasn't serving any purpose
Any
at all.
purpose. Okay.
Yeah. So we thought of using a distributed cache in that way.
Okay. So basically, you have multiple options. Either lambdas can call each other, or you can use a cache, or you can use a persistent storage if something
Yeah.
has to be stored for a longer duration of time. Okay. The other thing that bugs me a lot was that in our normal traditional programming, we have a concept of global variables, right? Where some variables can be shared across your entire application.
Yes,
Right.
correct.
For example, if you want to maintain some counters, if you want to maintain some shared state that your maybe threads are accessing, or your different classes are accessing, how does that translate into serverless computing? Like, how does global variables, or what is the equivalent of global variables in your Lambda architecture?
In that sense, think of it like this way. So the example that I gave earlier, you talked about counter thing, right?
Yeah.
Counter is a global variable which can be, or in certain cases, it has to be shared across multiple Lambda functions, right?
Yeah.
So that is how the like I talked about, step function manages it beautifully.
Okay.
Like it can take those decisions for you. You just have to define your step function in that way, right? You can say that this is the counter which is currently being maintained for this particular stage, and like the next level decision based on that. Say for example, you can say if the count is greater than 10, for example, then only invoke this Lambda function. Otherwise, you don't need to do anything. You can just terminate the entire workflow.
Okay.
So that is one way of handling the global variables.
So you sort of move that outside
Correct.
of Lambda, then in something
Correct.
called as step functions, and
Correct.
they take care of those sharing.
So in the response, the Lambda function has to, like in the request and response, it has to maintain that count and then hand it over to a centralized entity, which in this
Okay.
case is step function.
Perfect. Okay. So I think, yeah. So that is basically how global variables translate into a normal program. But recently, I read one article where it talked about how Prime Videos is actually moving from your microservice-based architecture to a monolithic architecture. Now, what they said was, I'm not sure whether it's really true or not, but what they said was that they were able to bring down the cost of operation by 90% when they moved from AWS, or using Lambda functions in AWS, to using EC2 instances in AWS. So what is the mystery behind that? Is there any theoretical or is there any practical limit to how much you can scale using Lambda functions, or is it suited only for certain kind of applications, and things like Prime Videos or streaming use cases are not a very good fit as of now for serverless architecture?
No, but they recently moved, right? So they had been using it for a very long time.
Yeah.
So I think scaling would not have been an issue because we have seen Prime Video performing really well.
Yeah.
Must have been something to do with the cost analysis, because Lambda can get very expensive in some cases if it's constantly being invoked, right? Because
Yeah.
we said that you pay for what you use. So if
Yeah.
you're using it all the time, there are chances that the cost will shoot up by a lot. So there is that factor. I think the cost would have been one of the major reasons for moving away from Lambda.
Yeah.
And I believe there might have been some trade-offs with respect to the simplification of the architecture. They probably might have realized that there are too many microservices to manage right now, and they are
Yeah.
not adding any value per se.
Okay.
So
So
they
yeah,
might
this I
have-
think is a very interesting topic. When you
Yeah.
have too many microservices,
Correct.
how do you manage these microservices? Like, because beyond a point it goes out of hand, right? So
Correct.
how do you monitor, or how do you see whether everything is working fine and as expected? So what do you usually do for that?
So in terms of monitoring, AWS has this CloudWatch mechanism, right? So CloudWatch can be used for logging, for publishing metrics,
Yeah. Okay.
for setting up alarms, so on and so forth. There are too many. It's also being used for triggering, like event-based trigger.
Yes.
Like you want to trigger a Lambda function at say every 1 hour, or using a custom regex. Then also CloudWatch can be used. So CloudWatch is the AWS service that's being used for managing the metrics, the
Okay.
performance. So there are certain predefined metrics which are all automatically being published. For example, if you're using an API gateway, the error count, the latency count, for if you're using the Lambda.
And CloudWatch is given to external users also?
Yeah, it is, right.
Okay.
Yeah.
Okay.
So CloudWatch is there. It supports query also on selective log groups.
Okay.
So it's beneficial. Like it's the auditing mechanism, I would say, when it comes to services and whatever systems you're using.
Okay.
Even the smallest of the metrics is being published to CloudWatch, and there are cases wherein you can even publish business metrics to CloudWatch. Say for example, metrics which are very specific to your business and does not really pertain to an AWS application per se. So those metrics you can also publish via CloudWatch.
Oh, okay. So it's basically a metric dump or some sort of a thing where you can dump your
Yes.
metrics and then you can have visualizations and
Correct.
dashboards.
You can build
and everything
dashboards. Yeah,
on top
all
of
those
it.
things. Correct. You can do
Okay.
that. Yes.
Okay. So, okay, I think the last point that I wanted to discuss was regarding security. Security is one of the major concerns for applications which are, or organizations which are a little skeptical about moving to cloud, because one thing is you move to AWS and Amazon actually holds control on AWS, right? So
Correct.
how do you ensure that for first use case Amazon is not taking or having a look at your data, and second, when you have multiple competitors running on the same platform, how do you ensure that there is no breach of data or there is no breach of any sorts which can hamper the company's performance or company's market growth or market representation. So how does AWS separates itself from an Amazon point of view, that Amazon does not have direct control on what AWS or what loads are running on AWS, and secondly, how does Amazon or AWS prevent sharing of data or breach of data amongst same competitors that are using the same platform?
Yeah, so when it comes to security, I think we have some of the really good encryption algorithms which are being used even when the data is in transit and even when the data is at rest. So it's not that anybody, the data is in the raw format, anybody can use it. There are very strict tenets around it. Depending upon the classification of your data.
Okay.
Obviously, for external partners, people who are onboarding, you would not want anyone to have that level of visualization.
Yes.
So I think the rules when it comes to the encryption of data, whether in transit or at rest, are very strict, and that's been strictly adhered to even within the company.
Okay.
So if you are building an application which has the potential of holding highly confidential or critical or restricted data, there are certain security rules that it needs to comply with.
Okay.
Yeah, so that is one part. And now coming to how AWS is protecting one business's data from another, I think I'm not really clear on that part, but I'm pretty sure they must have certain ways because I don't think they really segregate the data, so to say, because the
Okay.
data allocation is very random in that sense. I don't think they segregate one.
So you cannot have specific infrastructure dedicated to certain kind of.
I don't think I've not really come across cases, but I think these are the trade-offs that you usually make when you're onboarding a very big client, right? So you are sort of trying to make things easier for them. You are trying to build systems that would just satiate them.
Yeah.
So yeah, I think there must have been some ways, but I'm not really aware of it. But in terms of the data encryption, the how data is being maintained inside, it's very strict when it comes to encryption-based algorithms.
Okay. So I think that was a very interesting discussion. Thank you, Nathan, for being a part of this podcast.
Thank you, Shivam, for having me.
Okay, thank you,
Thank
everyone.
you. Thank you.
Thank you for watching this podcast, and do tune back to this podcast for more such interesting episodes. Have a good day.
Thank you.